let us call it hazard 1. Similarly, there may be a hazard that platform screen doors, they are unable to detect the obstruction, and they just close even if somebody is standing there. In that case, the passengers will be injured. There are several hazards. I will not count all of them because we don't have so much time, and I will just take one of the hazards and explain the process of determination of SIL. So as you are aware, SIL is not for an equipment. We can't say that this PSD has got a safety integrity level of 2. No, it's functions. Each function will have a safety integrity level. So in the beginning, without going into the design of the system, you list down all the hazards that can happen, and then according to the different components of the system, you assign which failure will cause which function failure will cause which hazard. So okay, let's come to the point number 1. That is, identify the possible hazards caused by function failure, and we will be taking H1, that is spurious opening of the doors, and we will assign safety integrity level to this hazard. The second step is to determine the worst case severity caused by the hazard. By you may brainstorming, you may do brainstorming of all the stakeholders and determine what are the possible causes. For guidance, Senelec gives 4 types of consequence of severity, and those are catastrophic, where a large number of people are affected. There may be multiple fatalities, some kind of head-on collision and all those things. The second, slightly milder one is critical, where a small number of people are affected. 1 or 2 fatality may also be there. Then third classification is marginal, where there is no fatality, but there may be severe or minor injury. Insignificant is possible minor injury and mostly discomfort to the passengers. So these are broadly classified in Senelec, but these are only guidelines according to your requirement. Apart from PSD, if you are doing for something else, according to your requirement, you can have your own categorization. So here in this case, the possibility for H1, for hazard H1, spurious opening of the doors, the severity might be classified as critical. Perhaps if you do the brainstorming, everybody will agree, okay, critical is the categorization of worst case severity of the consequence of this hazard. So suppose we take critical, then what is the next step? The next step is step number 3, find the maximum possible frequency for the acceptable risk, that is THR, tolerable hazard rate. Now from previous table, now we come to the next table, and here we see this table x-axis is the severity of consequence of the hazard, that is highest level is catastrophic, then critical, then marginal, and then insignificant. And on the y-axis, it is the frequency that can be tolerated. So we were dealing with H1, and we had said that, I will come to the previous one, we decided that severity caused by H1 will be classified as critical. Then we can come to the next table, and here for critical, find the maximum permissible THR, that is tolerable hazard rate for acceptable risk. Some kind of risk you will have to accept. And here in this graph, this is the alarm table. Green is acceptance of the risk without any further discussion. In yellow, it is something like tolerable, where you will have to, the SENELEC says that you will have to issue some directives, some guidelines, and then you can even go to this area, but you cannot go to this and this area. For undesirable range, only in extreme cases where it is not possible to reduce the risk further, and if all the stakeholders agree, perhaps you can accept this, but the red one is not negotiable. So what we have discussed is, for safety critical, severity is equal to critical, you have to stick to this y-axis, and this axis, the green one, that is highly improbable, corresponding to highly improbable, is accepted without any question. Then improbable, with some guidelines or with some special provisions, you can accept it. Rare and occasional, occurrence of this hazard is undesirable, and as I said, all efforts should be made to reduce the risk. But if not possible, then all stakeholders should agree, and maybe this can be accepted. But these two rectangles which you see, frequent and probable, is just out of question. Even if you can't say that I will meet and then try to negotiate. No, this is not negotiable. So this is the alarm table. In our case, for critical severity, there are only two options. That is, the hazard rate should be brought down to highly improbable or maybe improbable. So we have come to the third step, where we have excuse me, we have assigned the value of improbable or highly improbable for this particular hazard. So this becomes the THR. And now suppose we go for improbable, the THR might be something like 10 to the power minus 8. This again, it has to be quantified. So 10 to the power minus 8 per hour is the THR, which is permitted for this particular hazard H1, which is a spurious opening of the door. So finally, we say that, okay, spurious opening of the door will not be tolerated more than 10 to the power minus 8 per hour. And 10 to the power minus 8 per hour is something like 10,000 years of continuous operation of the system. Okay, so far we have reached up to this point, up to third step. Now, after this, the fourth step is, can we reduce the risk? That is, can we apply some risk reduction factors? That is, what if we provided an audio-visual warning system? A lot of people will be warned that door is opening, and this will reduce the probability of the occurrence of this failure. Or maybe we can say trains will pass at restricted speed when the doors are open. This will reduce the accident severity of accident. We can also provide that faults will be displayed on the maintenance panel so that somebody goes and warns the passengers. So there may be a number of risk reduction factors, and please note that whenever we apply these risk reduction factors, these go as SRAC, that is the safety related application conditions. So this will be traced from here to the O&M manual. So considering these factors, perhaps THR may be relaxed to less than 10 to the power minus 6 per hour. That is from 10 to the power minus 8 hours per hour. We can relax it to 10 to the power minus 6 per hour with the condition that all these and others, whatever we apply, these risk reduction factors have been applied. So we have seen the fourth step is identifying the risk reduction factors and finally coming to the post mitigation THR. Now we have come to the 10 to the power minus 6 per hour. Now, and this hazard might be caused due to failure of a number of functions. We have, see, our final aim is to assign a tolerable failure function rate for the functions, not to the hazard. So we will have to move from hazard to function, and for it, in this example, the failure of spurious opening of the doors may be caused by failure of door control unit, which is provided at each door. It may be caused due to failure of control system, or it may be false signal coming from the control panel. So now for these functions, we will have to assign the TFFR, and then we will go to SIL for these functions. So if you see the FTA, fault tree analysis, then DCU function failure, control system function failure, control panel failure, and these all have to be ORed, and then it will result into spurious opening, which is failure rate is less than 10 to the power minus 6. How do we assign TFFR to the different functions? We have to assign in such a way, based on the previous experience, we have to distribute or apportion this failure rate of 10 to the power minus 6 to these functions. An example may be DCU function should be less than 4 into 10 to the power minus 7, and so on. So if you add all of them, you come to 10 to the power minus 6. So here we have assigned TFFR for a function, for each function. So now please note that we have from hazard, we have come to the function failure. And now we, having known the TFFR, we apply the SIL table. This is a standard SIL table for Senelec. If the probability is probability of failure, or you can say TFFR, if the TFFR is required to be less than minus 8, then it should be SIL 4. If it is required less than minus 7, it will be SIL 3, and so on. So for this particular case, we see that for all the functions, the TFFR is required to be less than minus 6, 10 to the power minus 6, and more than 10 to the power minus 7. So it is SIL 2. So based on this, we assign SIL 2 to different functions of this. And now just another point comes. Oh, sorry. So this way it is SIL 2. Now there may be one more kind of mapping, that one function failure may cause different hazards. Then in that case, we have to take the most restrictive value of SIL assigned to that function. Suppose some other functions require that control system panel failure should be less than 10 to the power minus 8. Then that will be SIL 4. So here it is SIL 2 and there SIL 4. So we have to take the maximum one. OK, so we conclude this part 1 here, where we have seen 5 steps of assignment of SIL to different functions of any system and we have taken example of one of the hazards for PSD, platform screen door.
Yeah, we seems to have a question coming out, so maybe you can take that question now, or you want to wait. Yeah.
No, I will take that question. But
yeah,
I don't see it in the chat box.
Oh, it's in the ACRIT. Oh.
Yeah. Hello, sir.
Yeah.
Yes, please.
Hello, sir.
Can you put on your video and then ask the question, if possible?
Yes, sir. Yes. Yeah.
Yes, I can see you. Please go ahead.
Here, just not seeing this.
Do you want me to open some slide or what?
Yes, sir. This is the one. Yeah, this is the one. Here, this is the spurious opening of doors, and we have this TFFR values for these three failures.
Yes.
Yeah. Here you have given, for example, this is less than 4.0 to the power of -7. How you have given this? I mean, why don't we give this less than 4.0 to the power of -7? Are these?
See, we have to apportion this 10 to the power -6 in such a way that sum of all these should be 10 to the power -6. There is one way that you just blindly divide everything by 3 and come up with 3.3 into 10 to the power -7 for each of them. But by experience, if you know that some kind of failure are more likely to happen, or due to your past experience, maybe you will like to change it. Maybe you will make it 4, 3, 3. You can make 3, 2, plus 5, and so on. So it is a subjective matter. But normally, when we don't have any idea of the functions contributing to the hazard, we just divide it by 3, and then 3.3 becomes common for everything.
Yeah. You mean to say we will analyze separately for this TFFRs for that particular failures?
No, at this point, while assigning the risk, you will not analyze because you have no data to analyze. But from your previous experience, you can say that, okay, something is more likely to fail or something is less likely to fail. You will assign that way. Otherwise, as I said, you can just divide this 10 to the power -6 by 3 and then put equal number for each of them.
Yes. Clear.
Okay.
Yeah, thank
Good. If there is no other question, I will go to part 2. Okay. So part 2 is safety acceptance process. As I told you in the beginning, when you are using certain certified things, for example, the DCU may be a certified subsystem for the PSD, and so you need not go into the failure assessment of DCU. You can straight away assume something. So what are the conditions for that? First of all, you will have either a generic product or a generic application. So you will have some certificate for generic application. If you are doing it for the first time, it will be generic application or generic product. And the certificate which you will get from ISA is valid only for the first application. Okay, first specific application, that means whatever you have developed here, you will have to apply with the same features. You will have to apply to one system, and then again there will be assessment of that specific application, and you will get a certificate. But please remember this, even if there is a clear-cut certificate for generic application, it is not valid for any number of specific applications. It is only valid for the first one. So After getting the first specific application assessment and successful assessment, then two certificates will be issued together. One for this first specific application and another for the generic application process. So generic application assessment is complete only after the first specific application, and then you get these two certificates. Now this certificate, generic application, now it is valid for any number of specific applications. You can have all future specific applications based on this, but you cannot have, suppose you have got a certificate for a PSD gate for station number 1 specific application. You cannot use the same thing for getting another specific application. You will have to start from generic application certificate and then reach this point by adding whatever features you have added. So this is very important issue, that if you have a whole system installed at a platform, you cannot just take another one and take advantage of this this specific application and say that, okay, my another platform, I can use the same thing. No, you will have to start from generic application. So this is all covered in SENELEC 50129 section 8. And this is as per that. Any question on this? Yeah, Mr. Nazim, please go ahead.
Hello. Yeah, can I just add there, Dr. Verma, you know what you've just stated there, I agree with you, but you know this part here where you say once you've got a GASC or a generic application certificate from your first specific application, you can apply for other specific applications. For the example you gave with a PSD at a station, you can still apply that if the conditions satisfy the same generic application. So you don't need to keep on producing a safety case for every different station in that same geographic location. You just base it on the same specific application. I think I just wanted to make that clear. I think it was slightly misunderstood.
You can from one generic application, you can have several specific applications.
Yeah.
See, whenever you have installation, your project ISA will definitely like to issue certificate for the whole system. So even if, for example, PSD or example, say electronic interlocking, it is same. But everywhere, depending on the basic, it is issued as a certificate. Now, this is very clearly mentioned in 50129 section 8 that specific application to specific application is not permitted.
Yeah. Yeah, I think what Nazim meant is, I think what you said is also correct, is that if you have the same configuration across several stations, you can use the same specific application certificate. You don't need for different stations, isn't it? That's
that's right. I was just clarifying your point.
Yeah, that's correct. I think
if you, for example, if you use the same type of system, if you use the same DCU, if you use the same constituent materials, then yes, it is possible. But if you make any change, then what I meant is, if you make any change in this specific application, you cannot claim that I have made this change and with change with explanation or say impact analysis, I say that okay, from this I come to this point. It is not possible. If you make any change, you will have to come from here to here. From here you do the impact analysis, and then you come to here.
Yeah.
Yes,
Thank
it's
you.
just an example in the same line. Say, for example, if you have a intrusion detection system in the above ground area and which is not there in the underground area, then the configuration becomes different. Then you need two specific applications.
So,
but if you have the same configuration, then you have only one specific application in safety case.
Let me repeat it. If you make any change in this specific application, you cannot do the impact analysis and come to another specific application.
That's correct. Yes.
Then you have to come from here to here.
Yeah. Thank you.
Okay. Now, if there is no other question, I will go to our suite of courses that intellects. If you want to know more about it, and if you are interested in going into in depth in these areas, we have a number of courses. We have module level courses which cater to specific disciplines. For example, there is a course dedicated to system safety, that is 18 hours. And all these courses, module level courses, are approved by CPD. So you will get a CPD certificate. Then RAM engineering module, it is a 17-hour course, again approved by CPD. System engineering, 14 hours. System assurance, 9 hours. So these are the module level courses. If you want to go to a certificate course which encompasses most of these, you will we have got a railway RAM concepts and applications, that is a 41 hours course, again approved by CPD. Then there is a system engineering RAMs concepts and applications of 56 hours. And plus, of course, you will have contact sessions. This is also approved by CPD. Advanced certificate course is a 96-hour course. This is approved by IRSE UK. So these are the certificate courses. Then you have appreciation course, in which you will get a overview of the complete RAMs and system engineering. This is a live session, 2-day course, that is 16 hours. Next, we have introduced Emc Overview Course, which is a 4-hour course that is online plus contact sessions. So this gives you a comprehensive overview of electromagnetic compatibility as applied to railways. Then we have recently introduced EMC application on railways on team session, that is a 12-hour course. And in addition to these regular courses, we also have customized courses for organizations. If there is a sufficient number of candidates are provided by some organization, we can make a course available to all of them. So with this, I end my presentation. If you have any question on any of these items, of course, if you want to know more about the courses, please go to the website. You will get all the information, affiliation, etc. Or you can drop a mail. That is also mail is available on our website. Yeah, I think there is no question from anybody. So can we wind up the session? Yeah. Rishi, you would like to comment something?
Yeah. Okay. Thank you all for attending the webinar. The intention is that to share some of our experience and also trying to educate the railway community in the ramps and system engineering assurance. Overall, making the railway safe and reliable, every bit helps. So we are trying to do our bit by training the aspirants. Feel free to contact if there is any queries or if you want interested in training or anything. And feel free to send your comments as well on the webinar. So we try to improve based on your feedback. So feel free to put the reviews in the LinkedIn or just send it by email or something like that. Thank you all. Have a very nice weekend. So next week there is a webinar I'll be doing. It is on the asset inspection. So recently I have done a signaling asset inspection in a quite old railway. Normally the inspection is done by visual inspection, looking at the equipment condition, wiring degradation, and those kind of and functional tests and all. But that doesn't tell the whole story. Some reliability analysis using the life cycle distributions like Weibull or CROAMSA, that looking at the particular failure modes and how that is increasing or decreasing will tell whether it can be economically maintained or what exactly which that particular failure mode, what needs to be done. So all those things it can we can identify from the life cycle distribution, from the Weibull or CROAMSA, from the shape factors. There are tools we have used for the isograph, which has the Weibull distribution curves. So I would talk about the work done, and hopefully that would be helpful for you when you are into the projects or even the maintenance as well, especially for the maintenance. So I would invite you to attend the course next Friday at the same time. So we can see you all again. Okay, thank you all, and have a nice weekend.
Thank you.
Thank you, sir.
Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you.